Hi guys, Igor here. Today we'll explore regular expressions, also called regex. We'll do this in two languages, Java and Python, at the same time. So if you're interested, stay tuned, like the video, and let's start. Today we will cover input validation actually. So let's create a class in Java, new package called field validator. That, and we'll have a method here called isInteger isValid integer, which will take a string and it will tell us whether given string is in fact an integer. So let's write a regular expression to check that. Let's call it I don't know, integer pattern, for example. In Java we do pattern compile, and here we have our pattern. So what is the integer? It's basically a stream of digits, at least one, and optional minus sign. Let's ignore a plus for that. So let's say we need to have the beginning anchor to match the start of the text, start of the input, which is that. Then we can have a minus sign, but we'll make it an optional. And then we need to have at least one digit. So we can say, we can use this special meta character for regex, or we can do range with that. Basically is the same like doing that or doing that. Let's maybe go with range in that case, and we need to have at least one digit. So we use plus character, and let's also say ending anchor, because we only want to have digits there. Okay, and it should be enough actually. So here we'll say that string is not null, and it matches our regex. So matcher matches like that. And before creating a test, let's create the function file in the Python assert subfolder. Let's call it same as Java function field validator. Let's import RE package, which is for regex, and let's also create an integer pattern. And similarly, we have also compile method, and let's create the same regex guys as in Java, like that, plus, yeah. And let's create the same method is valid integer. We'll also accept string, and we check that string is defined and that integer pattern match. And let's wrap it into bool, because the string will return a string if it's defined, and here we will have none or match object, and we want to have a boolean, which in that case is called bool in Python. Okay, and let's create tests for that. So in Java we'll go to the test directory. Let's create a package Regex package, same as our new class. Let's create field validator test. And let's test it, guys. So we can create parameterized test with the method source. Method we'll call integer test cases, for example. Let's call this method, should validate integer. We'll have two arguments, string and information whether it is valid, should be valid or not. Here we do assertions, assert equals valid, and we'll call our method like that. Okay, and let's create integer test cases. We'll do this like that, stream of arguments, integer test cases, stream of, stream, so at least one object, and the argument is just an array of objects. For us it is a string and boolean. So here we have a cases like 22, it is valid, then let's say minus 22, it should also be valid. Let's maybe do 2, then a few digits, I don't know, like that. Same with minus. Let's maybe do also 0, like that. And let's do ones that shouldn't pass, like empty, null shouldn't pass, some strange signs shouldn't pass, the number with some letters shouldn't pass, and maybe only letters, and maybe, I don't know, letters and digits afterwards, because we have digits and letters after, and we have letters before digits here. Yeah, it should be enough. That's right. Okay, it passes. Let's do the same in Python. So let's create a test field validator. In Python, convention is reversed. Like that. Let's import test case from unit test. No, from test case, from unit test, import test case, and class test field validator, which extends test case, and the same test case almost. We need to prefix our method with test, and then also should validate integer. And parameterized test in Python we can do like that, test cases for now empty, and we say that for string and valid in test cases, this will be tuples. We will do with self subtest. Here we specify the arguments, valid string, and here we call self assert equal, similarly as with Java. Let's from assert let's import our field validator. and let's call it method actually. Okay, something like that, and we need to have cases. So let me copy them. Okay guys, we have almost the same list of tuples, so let's run our test. Okay, it passes. Okay guys, but let's see if it works from the terminal also, but because with Python you never know. Okay. Okay, so here we have output, but let's make it verbose. And here we have a test, should validate integer, which is our method, and our class. Okay guys, so we have an integer, let's do double. So let's do this in Python first. So we will go with a similar thing really. Let's copy that, and here let's use the D symbol instead. And here we need to have a stream of digits, and then depending on the locale, people are using either period or comma. So let's support both actually. So comma, period, and then also at least one digit. And I think we need to do that. Python or not, we'll see. So yeah, and ending anchor. Yeah, they don't. Yeah, let's actually do that. I think we need to, but we will see. And is valid double string, and let's not forget that integer is also valid double. So what I would do is to do something like that. And here and double pattern match string and not and but or this integer pattern. Yeah. So or, because as I said, valid integer is also valid double. And let's add a test case actually. So maybe copy that because it will be pretty similar. Let's say test should validate double. We will change that. We will change the test cases. Here is valid double. Children are going upstairs, the background. Okay, and actually we can keep a few of these cases. Maybe something like that. And let's add to true with also with the comma. Maybe also something with a few places after the comma, and let's do something with the minus actually, something like that. Yeah, I think it should suffice. Maybe also something, a few digits before period and after. Here we have minus with 1, maybe also minus with, I don't know, something like that. Yeah, should be enough. Here, let's maybe add a blank. And these cases can be almost the same, I would say. Maybe add also one like that. Maybe here, a few places, a few digits after period. And here maybe something like, I don't know. Yeah, lots of cases, guys. And let's run a test. Okay, it passes. So maybe validate that the minus is working. Let's remove it. Some tests should fail. Yeah, they fail. Minus and minus. Only two cases. Interesting. This should fail. Oh, the integers didn't fail because of that. If we comment out, we change that. Yeah, more cases. Okay, but let's get it back and let's do this in Java, guys. Delicious, delicious coffee, by the way. Okay, so let's copy that. Let's say double pattern. Let's copy the pattern. Should be the same. Yeah. And is valid. Double. So string, also string, not null, and double pattern matcher matches, or integer pattern matcher matches, right? Okay, let's maybe format it like that. Let's also copy that. Let's change it to should validate double. Here is valid double. Let's change it to double test cases. And let me copy that, guys, fast, what we have here. Okay, we have double test cases. Let's run them. They pass, 20 cases. Here we don't have a breakdown in Python. That's unfortunate. Okay, guys, let's do the last one, which is name pattern, I would say. And it's really up to us what it means. I would say that our name should begin with a letter, with the ASCII letter. So let's state that with the anchor also, and then we should have some characters. I don't know what characters, but some. I would say that from 2 to, I don't know, 90. So in total our name can have from 3 to 20 characters. Here for the characters you can also use that. Maybe let's do that. And let's also allow, I don't know, digits like that. Yeah, it is more readable readable like that, I would say. Digits and I don't know, maybe dash and underscore. Something like that. And what's wrong? You guys. Oh yeah, not plus, but from 2 to 90. Okay. And let's say that is valid name. Similarly to previous ones, we have the not null string and the name pattern matcher matches like that. So let's write a test similar to previous ones. We say name test cases should validate name, and we'll say is valid name like that. And let's write the name test cases. So name test cases stream off as previously, arguments off. And what is a valid name for us, guys? It needs to start with the character. So this is a valid name, for example. Also something with this is a valid name. So maybe start with the something like that. What else? This is a valid name. Actually, even something like that is a valid name. Not started with the letter is not a valid name. Name with the white space or with a space it's not a valid name. So this is not a valid name. Yeah, false. And this is also not a valid name. And also something like that is not a valid name. And blank name is not a valid name. And I don't know, null is also not a valid name. And something short like that is also not a valid name. And too long name. How we can generate that? Maybe like that. Too long name. Let's say string join. Stream generate. I don't know. C limit 21. Joining like that. We have C times 21. So let's use it here actually. And let's say too long name like that. And let's run it. Okay, it passes. Let's check that. What will happen if we will change it to 20, not 21? It should fail. Long name, yeah. It failed. Do we have enough cases? Yeah, I think so. So let's port it Python. Let's maybe run all tests again. It shouldn't matter, but you never know. Okay, everything works. So now the Python version. Again, name pattern, recompile, same pattern as in Java, which is nice, and is valid name. Valid name, string, bool, string, and name pattern match string. Like that. And test cases, guys. So let's what happened here, guys. We don't want to have any column there. Let's copy the case. Test should validate name like that. Something went wrong with formatting, I think. We will fix that. Let's see. Oh, yeah. Okay. It's valid name, opposite face. So let me copy the cases. Python. Okay, guys, almost there. I still left out only the too long name because I wanted to show you. So here we will do this. Java, we have used the stream. Here let's do the list comprehension and do something like that. 21. And yeah, it should work in the same manner. Okay, something is not working. Let's see what happened. Okay, is valid name. Let's see. String and name pattern. And yeah, name pattern is the same. Yeah, that one. Java, it's passed. Yeah, it passed because the matcher, it works slightly differently in Java. Matcher matches. It adds anchors by default, I think, at the beginning, at the end, but it's still more readable to specify the regex like that. So now it should work. Okay, doesn't in one case. So yeah, that why? Yeah, because it is of length. Let's check out the length. The length of the long name. It will be 21 probably. Yeah, because it is inclusive, not exclusive like in Java. So Java, where we do this with stream, we are saying that we want to have 21. Yeah, 21. So it should not. This is good because we are allowing to have we are allowing to have 20 characters, but not 21. So why it doesn't work, guys? Too long name, 21, and okay. Yeah, need to join that to create a string, not all right. Yeah, it works. It works. as it should. Let's run all tests together. They pass from command line. They also have passed. Yeah, so I think that's it, guys. This is how you can use the Regex for input validation in both Python and Java. We'll cover other use cases in the next subsequent videos. So if you like the video, subscribe to the channel, and I see you in the next one. See ya!